Hello everyone, welcome to this video. In this video, we need to prove that whether a group G is abelian. If it is abelian, then this condition would hold that AB whole inverse that is equal to A inverse B inverse. Or conversely, if this condition holds, then our given group G is abelian. So let's solve this question. Let's prove this result. So here we first of all assume that the given group G, let this be an abelian group, correct? We first of all assume this thing with us. So what we need to prove? So we need to prove that AB whole inverse is equals to A inverse B inverse for all A and B which are member of this group, right? So for that, what do? We consider the left hand side. So we consider the left hand side, right? What is it? It is equals to AB whole inverse. Now according to socks and shoe property, right? You know, we have studied about this property in the previous videos. This thing is equal to B inverse A inverse. And furthermore, because we know G is abelian, right? And if A and B belongs to G, then surely A inverse and B inverse also belongs to the G, right? Then surely they would also commute with each other. Hence, A inverse B inverse would be equal to B inverse A inverse. So using this property here, we can write it like this: A inverse B inverse, right? By commutativity. So from here we have, what is it? It is your right hand side. So from here you have the left hand side equal to right hand side. Hence we have a result. Conversely, we assume that let AB in whole inverse is equals to A inverse B inverse, correct? What we need to prove? We need to prove that G is abelian, correct? That is, we will prove that AB is equals to BA for all AB which are member of G. We need to prove this thing. So for this, what do? We consider whatever that is given to us. So this is given to us, right? This thing is given to us. So from here, using this expression, so let me write down, this is given to us. So here you can apply the sock shoe property on the left hand side to obtain this thing, right? So from here, applying the sock shoe property, we have our left hand side, right? Now what you can do, you can pre-multiply both sides with B, so that you would have B A inverse B inverse, right? So this is by pre-multiplying with B, right? So once you solve this, you have B inverse is E A inverse is equal to B A inverse B inverse, which implies A inverse is equals to B A inverse B inverse. Now what we can do, we can pre-multiply with A on both sides, so that we would have A inverse is equals to A inverse B inverse. So what we are doing, we are pre-multiplying with A, right? So here also it would become E is equals to A inverse B inverse, right? Next, what we can do, we wanted to get rid of these inverses, so we will post multiply by B on both sides. So it would be EB is equals to A inverse B, right? Post multiplying with B. So this would give us B is equals to A inverse, correct? Now what we can do, we can again post multiply with A on both sides, right? So what we can do, we can post multiply with A on both sides, so that we would have BA that is equals to AB into E, which is BA is equals to AB, and this thing is true for all AB which belongs to G, and this is what we wanted to prove here. Hence our result is proved. hence G is abelian. So I hope you understood this result well. Well, that is it for this video. Thank you for watching.